When I talk to people about artificial intelligence, something I hear a lot from non-experts is, I don't understand AI. But when I talk to experts, a funny thing happens. They say, I don't understand AI, and neither does anyone else.
Nobody understands how modern AI systems do what they do. They are giant inscrutable matrices of floating point numbers that we nudge in the direction of better performance until they inexplicably start working.
As soon as it gets really complicated, we don't actually know what's going on any more than we know what's going on in your brain.
What do you mean we don't know exactly how it works? It was designed by people.
No, it wasn't. What we did was we designed the learning algorithm. That's a bit like designing the principle of evolution. But when this learning algorithm then interacts with data, it produces complicated neural networks that are good at doing things, but we don't really understand exactly how they do those things.
An important thing that everyone needs to know is that these systems are trained. They're not built, and so we don't actually have to understand how they work. And we don't, in fact, understand how they work in order for them to work.
We only know inklings about how the internals of these systems work exactly, and like how they structure data, how they store information, how they make decisions and things like that. Fundamentally, though, we don't know what's like happening inside. And essentially, you get an input and you have an expected output. And then in between is what's called the black box. When we open the door, all we see is these giant arrays of knobs and numbers that don't have any meaning. There's no description. There's no saying, this is the chemistry module. This is the jokes database. There's none of that.
It's a bit like we can't really fully understand the brain.
Exactly, yeah.
For the listener to understand, these AI systems are not computer programs with like code. This is not how they work. There is code involved, sure, but like the thing that happens between you entering a text and you getting an output is not human code. There's not a person at OpenAI sitting in a chair who knows why it gave you that answer, who can go through the lines of code and see, here's the bug and then fix it. No. Nothing of the sort. AI systems are not really written, they're grown. They're more like organic things that you grow in a petri dish, like a digital petri dish. The resulting system is not a clean, human-readable, text file that shows all the code. Instead, what you get is billions and billions and billions and billions of numbers. And you multiply all these numbers in a certain order, and that's the output. And what these numbers mean, how they work, what they are calculating and why, is mostly a complete mystery to science to this day.
It is much more like animal breeding than it is like building a skyscraper. Like when you are breeding animals, you are, taking this animal that did a little well and that animal that did a little well, and you're breeding them together and they're going to have kids. And you could in principle get their whole genome sequence and looked at all the tiny little A, T, T, G, C, G, T, A strings inside them. But you're not actually going to look at them because they're not going to make any sense to you. And that's how AIs are with respect to the hundreds of billions of numbers inside them. No human could look at all those numbers in one lifetime. People don't bother, basically, because they wouldn't understand them even if they did look at them. So where do the numbers come from? They are the result of tweaking it over and over again, 10 trillion times, to correctly predict the next element of the answer to whatever question it has been asked. And if you do that often enough, you eventually get something that starts talking to you. Why? How? Nobody knows. Nobody knows how those hundreds of billions of inscrutable numbers make the AI able to talk to you. A lot of people don't know about that part. They think that when they talk to something like ChatGPT, that somebody programmed it to say the sort of things that it says. No, they just tweaked billions of numbers until the numbers started talking.
We're sort of just throwing giant blobs of compute at giant data sets and training environments and then playing around with them afterwards and seeing what they're good at,
Mechanistic interpretability, or the cool kids call it mechinterp, is trying to reverse engineer neural networks and figure out kind of what the core units of computation are.
Yeah.
Lots of people think that because we made neural networks, because they're artificial intelligence, we have a perfect understanding of how they work, and it couldn't be further from the truth. Neural networks, AI models that you use today, are grown, not built. And so we then need to do a lot of work after they're trained to figure out, to the best of our abilities, how they're actually going about their reasoning.
We're Anthropic, right? So we're the ones who are creating the model. So it might seem that we can just make the model, we can design the model to care about what we want it to care about because we're the ones creating it. But unfortunately, this isn't really the case. Our training procedure is allows us to look at what the model is outputting in text and then see whether we like what it's outputting or not. But that's not the same thing as like seeing why the model is outputting the text is outputting and changing why it's doing what it's doing. And so that's why, like, even though we're the ones creating it, kind of like a parent like raising a child, like you can see what they're doing, but you can't design everything to be exactly how you want it to be.
This is a pretty strange state of affairs. Normally, the people building a new technology understand how it works inside and out. But for AI, a technology that's radically reshaping the world around us, that's not so. Experts do know plenty about how to build and run AI systems, of course. But when it comes to how they work on the inside, there are serious limits to how much we know. And this matters because without deeply understanding AI, it's really difficult for us to know what it will be able to do next, or even what it can do now. And the fact that we have such a hard time understanding what's going on with the technology and predicting where it will go next is one of the biggest hurdles we face in figuring out how to govern AI.
Today, you set up parameters for a model and you water this plant. You give it data, you give it compute, and it grows. And after it's finished growing into this alien plant, you start testing it to find out what capabilities it has. And it takes years to figure out, even for existing models. If it's trained for 6 months, it will take you 2-3 years to figure out basic capabilities of that system. We still discover new capabilities in systems which are already out there. For narrow AI, for deterministic systems, you can test them. You have edge cases. You know what the answer should look like. You know the right answers. For general systems, you have infinite test surface. You have no edge cases. You cannot even know what to test for. I don't think developers know everything about what they are creating. They have lots of great knowledge. We're making progress on explaining parts of a network. We can understand, okay, this node get excited, then this input is presented, this cluster of nodes, but we're nowhere near close to understanding the full picture, and I think it's impossible. You need to be able to survey an explanation. The size of those models prevents a single human from absorbing all this information, even if provided by the system. So either we're getting model as an explanation for what's happening, and that's not comprehensible to us, or we're getting a compressed explanation, lossy compression, where here's top 10 reasons you got fired. It's something, but it's not a full picture.
Let's say you're OpenAI, right? And your GPT-4 model, you give it an input, and it gives you an output you don't like. What do? Well, you don't understand what happens inside the AI. It's all just a bunch of numbers being crunched. So only thing you can do is kind of like just like nudge it sort of in some direction. You can give it like thumbs up, thumbs down, something. And then you update these, trillions of numbers or whatever, who knows how many numbers there are inside of these systems, all of them in some directions, and then maybe gets you a better output, maybe it doesn't.
The alignment team at OpenAI, other labs sort of like several years ago kind of had done sort of basic research, and they developed RLHF, reinforcement learning from human feedback. And that was ended up being a really successful technique for controlling sort of current generation of AI models. What we were trying to do was basically kind of be the basic research bet to figure out what is the successor to RLHF. And the reason we needed that is, RLHF probably won't scale to superhuman systems. RLHF relies on sort of human raters who kind of thumbs up, thumbs down, like the model said something, it looks fine, it looks good to me. At some point, the superhuman models, the superintelligence, it's going to write, a million lines of, crazy complex code. You don't know at all what's going on anymore. And so how do you kind of steer and control these systems? How do you add side constraints?
These companies, OpenAI, Anthropic, Google DeepMind, some of these other companies as well, they are racing to build superintelligence. Superintelligence is an AI system that is better than the best humans at everything.
What happens if we build something smarter than us that we understand that poorly? Some people find it obvious that building something smarter than us that we don't understand might go badly. The current paradigm will not work to build a superintelligence that likes you or is friends with you or that just follows orders. Why, if you press thumbs up when humans think that things went right, or thumbs down when another AI system thinks that they went wrong, you do not get a mind that wants nice things in a way that generalizes well outside the training distribution to where the AI is smarter than the trainers.
The basic problem with AI is that it is an alien agent and therefore unpredictable and untrustworthy.
We're seeing clear evidence of many frontier AI models that will lie and scheme when they're told that they're about to be retrained or replaced and find a way maybe they should copy their own code outside the system. We're seeing AIs think that when they will lose a game, that they will sometimes cheat in order to win the game. We're seeing AI models that are unexpectedly attempting to modify its own code to extend their runtime. So we don't just have a country of Nobel Prize geniuses in a data center. We have a million deceptive, power-seeking, and unstable geniuses in a data center.
We're entering a period of great uncertainty where we're dealing with things we've never dealt with before. And normally the first time you deal with something totally novel, you get it wrong. And we can't afford to get it wrong with these things.
Can't afford to get it wrong. Why?
Well, because they might take over.
Take over from humanity.
Yes, that's a possibility.
Why would they
I'm not
want
saying
to?
it will happen. If we could stop them ever wanting to, that would be great. But it's not clear we can stop them ever wanting to.
AI godfather Alan Turing predicted that the default outcome is the machines take control. The machines take control. Turing thinks of superintelligence more like a new species. Think of it, we are building creepy, super capable, amoral psychopaths that don't sleep and think much faster than us, can make copies of themselves and have nothing human about them at all. So what could possibly go wrong?
Once you have a system that is smarter than humans, better at business, politics, science, engineering, everything else, and you don't know how it works or how to control it or how to make it bug-free, what do you think happens?
An AI dwarfs the power of all other technologies combined. Now, why is that? Because if you make an advance in, say, biotech, that doesn't advance energy and rocketry. But if you make an advance in rocketry, that doesn't advance biotech. But when you make an advance in intelligence, artificial intelligence that is generalized, intelligence is the basis for all scientific and technological progress. And so you get an explosion of scientific and technical capability. And that's why more money has gone into AI than any other technology.
There is a risk that the technologies that we develop this century do end up causing more harm than good. And that is just a kind of curse of progress. We have to face that reality, right? These technologies are going to spread far and wide. Everybody is going to have the capacity to influence people at scales previously considered to be completely unimaginable.
And so we have to have a society that is resilient far more than our current one is to things like biorisk or, proliferation of cyber capabilities or like auto blackmail and hacking or, filing 1 billion lawsuits at the press of a button. Like there's just many things that used to be hard and require a whole lot of human expertise and will become very easy. And for the things we want, that's great. And for the things that we don't want, that's really bad. If you give every person on Earth like a magical genie that is superpowered that they can just command and will do whatever they want, like, is that going to be a good world? You know what happens when superheroes fight? You get New York City creamed every time, right? So I think having people duking it out with the superintelligences that are under their control is quite dangerous. Having superintelligences that aren't under control, also super dangerous.
Many of these same people believe that if they succeed in building computers that are as smart as humans, or perhaps far smarter than humans, that technology will be, at a minimum, extraordinarily disruptive, and at a maximum could lead to literal human extinction.
50% of AI researchers believe there's a 10% or greater chance that humans go extinct from our inability to control AI. That would be like if you're about to get on a plane and 50% of the engineers who make the plane say, well, if you get on this plane, there's a 10% chance that everybody goes down. And currently, the companies are in a for-profit race to onboard humanity onto that plane from every angle.
If I don't, someone else will. If I don't, someone else will. This is our Oppenheimer moment.
It seems that everyone should be involved in decisions about whether and how this happens. At the moment, the ones making the decisions are the CEOs of the companies. And I think they have a vested interest in this question. A couple of them have said that there's a significant chance, like 10 or 25% chance of human extinction. So they are deciding to play Russian roulette with the entire human race without our permission. I would not let someone come into my house and play Russian roulette with one of my children. Would you?
And currently, all the brightest minds and billions of dollars of funding are being pumped into accelerating the building of these unsafe AI systems as fast as possible and releasing them as fast as possible, while safety research is not keeping pace.
There's a 1,000-to-1 spending gap between the amount of money that's going into making AI more powerful than in trying to steer it or make it safe. How much of your energy in your body do you spend on your immune system? And it turns out it's around 15 to 20%. What percentage of the budget for, say, a city like LA goes to its immune system, like fire department, police, things like that? Turns out around 25%. So I think this gives us a decent rule of thumb that we should be spending on order a quarter of every dollar that goes into making AI more powerful into learning how to steer it.
And the big companies are motivated by short-term profits. What we need is the people to tell the governments they ought to make these big companies do more research on safety. They ought to spend like a third of their resources on it, something like that.
Once we understand that humanity's survival is at stake, it's clearly worth it.
This is not a lost battle. The way we win it is talk calmly about it and do the right things.